Alrighty. Looks like the streak will be broken today. All 12 of it. Okay. Minimum initial energy to finish tasks hard. Begin an array task where task I is equal to actual sub I minimum sub I. Actual is the amount of energy you spend to finish the ith task. Minimum is the minimum of energy you require to begin the ith task. For example, if the task is 10:12 and your current energy is 11, you cannot start this task. Because 12 is bigger than 11, I guess. How if your current energy is 13, you can complete the task and your energy will be 3. Okay, you need to have at least 12, but it actually takes 10. You can finish the task in any order you like. Return the minimum initial amount of energy you will need to finish all the tasks. Okay. So here's 8. So if you start with 8, that would allow you to do this task. Drop down 4, and then you have 4, and then if you have 4, then you can do this task. It requires you to have at least 4, but only uses up 2, so then it becomes 2. So yeah, 8. Yeah, 8 minus 4 minus 2 minus 1. So here you need to start with 32. Probably do this task first. And then you have 22, then you do this task. Minus 10 is 12, 12 is enough to do this task, minus 8 is 4. 4 minus 4, 4, actually, did I do the math wrong? 32 minus 10 is 22, minus 10 is 12, minus 8 is 4. Did I get the order wrong? Interesting, you're supposed to do this task first. 32 minus 1 is 31, minus 10 is 21, minus another 10 is 11, minus 8. How did this work? 32 minus 1 is 31. Oh, it did this one first. Or this the one second. Minus 1 is 31, minus 2 is 29, minus 10 is 19, minus 10 is 9. Wow. I guess if you just, it's definitely not the case. Well, definitely this is an example there where you shouldn't be doing kind of highest minimum requirement first. What about this one makes it really weird, huh? I guess if you just try to do this early. Why is this one the one that you want to do last? I guess if you have a minimum of 9 and you're taking 8, then if you're actually leaving this as kind of your last, or if this isn't your last one, then you would need to have something where like you're starting with maybe like if you're trying to get this to be your lowest one, if you're pushing this closer towards your later ones, or maybe what am I trying to say here? If this is one of your early ones, then like why would you want to do this first or last? If you're doing this first, then you're not really getting much of a benefit. Is that right? Is the benefit there's something to do with the difference between the minimum and the amount that you're spending. Seems like maybe you're supposed to be somehow prioritizing the bigger gaps first. Why is that? Because if you have 9, if you start this thing with 9, and then you take away 8, then you're down to 1. If you're down to 1, then you can only do like a 1, 1 or a 0, 1. You can't really do anything bigger than that, right? Okay, let's see this last example. So in theory, this is the 6 gap, 6 gap, 6 gap, 6 gap, 6 gap, 6 gap, okay. So I mean, my theory would be probably want to have, they're all 6 gaps, so it really makes no difference. You probably want to have this last. So you want to have 7, and then at that point you need to have a 6 higher than 7, so plus 6 plus 6 plus 6, so 1, 2, 3, 4, 5, so it'd be 37. Guess that didn't work. 6 gap, 6 gap. So starting with 27. 27. I feel like you should be able to do any ordering here. You start with 27, let's say you do this one. So taking 6 away, so that's 21. And then you do this one. Taking 5 away, so that's 16. Then you do this one, you take 4 away, so that's 12. And then you do this one, take 3 away, so that's 9. Then you do this one, take 2 away, that's 7. So the order here didn't really matter, I don't think. Not really, I mean in terms of, actually why did plus 6, plus 6, 1, 2, 3, 4, 5. What am I'm somehow miscalculating this. Oh, no. Starting with 27. Two, 3, 4, 5, 6. 2, 3, 2, 3, 15, 20, 15, 25. 2 plus 3 plus 5 is 10. 4 plus 6 is 10. 20. 20 plus 7. 27. Is that the math? Is actually adding the minimums to the 7? I guess that makes sense. Adding the minimums to 7. Oh boy. That's a really high acceptance rate. Okay. Guess I really just need to worry about how to tackle this. Turn the minimum amount of energy. So this is 10 to the 5th. This is a task. So it's probably like binary search is my guess. Or linear. Linear doesn't seem like it'd be likely. Probably binary search. So this one was literally like 7 plus 2 plus 3 plus 4 plus 5 plus 6. And this one was like maybe 9 plus 1 plus 2 plus 10 plus 10, something like that. Nine plus 1 is 10, plus 10 plus 10 is 30, plus 2 is 32. So I just need to figure out what the appropriate one is, what the appropriate like last task is, and then maybe add the minimums to it. Although I can think of maybe, can I think of an example where that wouldn't apply? Can I think of an example where that wouldn't apply? Where I'd have to, so let's say this one was, the last one was 2 plus 2 plus 4. Let's say it was something like 1, 2, yeah, if it was something like 1, 2, 20, 40, and then maybe another 20, 40. No, maybe like another 1, 2. So here the answer should probably be like 40. But if it was just like 2 plus 20 plus 1, that wouldn't be 40, right? Yeah, this one should be 40. So it's, so this one, so in the ideal case, it's like the minimum or the, yeah, the minimum of one of the tasks plus the energy requirement to do the other tasks is kind of your ideal case. Or maybe it's your almost typical case. Maybe I need to, maybe I need to somehow visualize this. 1, 2, 1, 2, 2, 4, 4, 8. 1, 2, 2, 4, 4, 8. How would I visualize what's going on here? So if I think about an energy bar decreases, needs to be above a certain level. So 2, 4, 8 are the levels. So like, let's say requirements, need 2, 4, 8, need 2, 4, 8, and then the subtract subtract 1, 2, 4. What does that mean? So I have a certain energy level. It needs to be above a certain level. And then it needs to subtract. And after subtraction, it needs to be above the remaining energy levels. All of them. Needs to be above the remaining energy levels. Wonder if there's a fast way, if I knew like what the final one was, if I knew which of the tasks here was the final task, can I come up with the fast calculation for how fast it would be to do all the other tasks, such that I end up with a certain task as the final? Maybe. It'd have to be almost like pre-calculated, because it can't be recalculated each time. That'd be n squared. Like for every element in the task array, it can't somehow say if this is the final task, calculate every other task surrounding it. That'd be n squared. Hmm. 40. 40, 40, 40. If this was something like, let's say, there was a 40, maybe there was a 35, 30. This would be much bigger than 40. This would be, I'm guessing, something like 55, it looks like here, unless I'm calculating this wrong. Looks like maybe it gets 55. Okay, yeah, so it's like 35 plus the 20. And then the 1, 2, it's just, can be done after that. Although if this wasn't 1, 2, if this was say 10, 10, then this might be 65 or 60. 60. So 30 plus 20 plus 10. No, sorry, it's 35 plus 20. How did this end up being 60? Is the better way to calculate it by 30 plus 20 plus 10? So if it's 60, then you do this one first. That brings it down to 40. Then you do this one, that brings it down to 10. And then you do that one. Huh. Oh, indeed. Oh. Oh, a certain energy. And then you start subtracting. Like I feel like it, so it's definitely not brute force. It's definitely not brute force. Okay, let's think about like upper bounds for this. What is a guaranteed upper bound? Kind of what's the minimum or maximum needed? Something like that. Let's say upper bound of the number of energy that you need would be. I mean, if you do the sum of all kind of requirements, yeah. If you do the sum of all requirements, that has to be the upper bound, right? Yeah, that has to be. So then what's a lower bound than that? And I guess the lower bound would be like sum of all costs. Assuming that it's okay, let's generate task is list of costs, requirements. You can't go lower than this because then you just wouldn't have enough energy to do all the tasks. You wouldn't need to do higher than this because yeah, it shouldn't be necessary to do higher than that. So the question then becomes where between those two. I wonder if I can do binary search here. No, I don't think so. Binary search. Which has to be some sort of elegant way of determining, I think. But then, what would it be? What would it be? How would you go about doing the task? This one is very, very interesting. This example. Doing the task with the lowest requirements first, even the lowest costs first. Lowest cost, lowest requirements. It's a huge. I guess you could have reordered this. I guess the only thing that was really required in this solution was that you did 8, 9 last. Any other ordering would have worked, assuming you started with 32 energy. But if you start with 32 energy, you could not actually do 8, 9 first, or anything besides 8, 9 being last doesn't work. Because if you do 8, 9 and it's not last, then what? Then I think somehow your gap between your required energy and the actual energy is not big enough. So if you have 32 as your starting energy, you can do something that is requiring 32 or less. Requiring 32 or less. But if you did 8, 9 first, then the 32 would become What does that mean? You did 8, 9 first, then you take 8 away, so you have 20, 23, or 24. 24, 24 energy. No, you could, maybe you could have actually done, you're left 24 energy minus 10, and you're left with 12, or 14 energy. 14 energy minus 2 is 12, minus 1 is 11. And I guess maybe you could do 10, 11 last as well. 10, 11, or 8, 9 last, you can't. But you can't leave 1, 3, 2, 4, or 12, 10 last. Yeah, because then if you did those last, then in theory, you'd have 2 energy left. And if you had 2 energy left, then that means that you would have started with 33. You would need 33 energy. So, moral of the story is you want to leave the task that has the lowest imbalance last, because that means you have the least amount of excess energy at the end, kind of. Excess energy being if this was if there was only one task and you had some higher amount of required than cost, then whatever leftover is whatever is left over, right? That's your excess. So you want to have the task with the lowest excess required over cost should be your last task. Guess that makes sense. So you probably want to do this one last, even though in theory they're kind of equivalent. 8, 9 versus 10, 11. So if you did this one last, and then you did this one second last, then how would that have just not changed your excess? So you ended up with an excess of 1. So you needed 9. 9 plus 10. 9 plus 10 versus 8 versus 11 plus 8. So it's the same as 19. Okay. So if this was your last one, then you would need to have 9 before it. And then you would need to have spent 10 to do this one second to last. So then you need to have 19. And because 19 is bigger than 11, then it doesn't really, you don't need to have excess capacity there. Okay, I think I have an idea. So for every task in the task array, I'm going to form a special tuple that is like, this will have it'll have excess, and then I want to sort by, I think I want to sort by, I guess if it's excess then it doesn't, it's just a single value here, excess and cost, or excess and then excuse me, I guess excess and I think I want requirement for each task. Okay. Excess and requirement. So tuples dot append, say the tuple that is task requirement, which is index 1 minus task cost, comma task requirement. And then I think I want to sort. Yeah, so this is 1 excess. So it needs to start off with at least 9. 9 is the baseline here. And then from there, what do I do here? Yeah, I kind of want, maybe I do want the cost. That makes this a lot easier for me to parse. Yeah. Yeah, it's strictly not necessary because I could always recalculate it, but it's so yeah, it starts with 9 energy. And then you add 10 energy. So you have 19. 19 is bigger than 11, so you don't need to, like, if this was something bigger, let's say this was required. If this was 30, would you really bump it up all the way to 30? If it's smaller than this sum, 9 plus 10 is bigger than 11, then I don't need to worry. But if this was bigger, like 30, am I going to bump it all the way up to 30? So then I'd have 30 energy. I'd have 30 energy. And then what I need to actually have, it probably affects my later orderings. Like if I have 30, I don't think I need to add 1 here. I need to get to 60 here. So in theory, I'd have 10 as my low here. So I start with 10. And then I add 30 and then 20. 10 plus 30 is 40. 40 is bigger than 35. Okay, I need to test this thing. What happens here? Okay, they're not good enough numbers. Let's say this was 80. I think the answer here should be 80. The answer is 80, but so I have 10. This leads to 60. 60 is required. Should I be sorting not by excess but by the minimum requirement? From low min? No. Like I didn't want to sort by minimum requirement is because this of the second sample. So there's 0 excess here. So in theory, this is what I want to end up with. And then there's 30 excess here. Ten plus 30 is 40. 40 is smaller than 60. So I need to bump it up to 60. But of the 60 here, I'm just using 40 of it. So I currently have an excess of 10. No, I have an excess of I have an excess of 0 plus, I have an excess of 20, right? I have 60, spent 40, I have an excess of 20. What does that mean? If I have an excess of 20 and my starting energy is 60, here it's like 60, spend 20. No, 80, 20. So I'm at 60 energy. I'm at 60 energy. I don't think it's because I'm adding 20 to get 80 here. I think the 20 there's whatever. I think it could be something bigger, like let's say 30, 80. I think that should still be starting with 80. Starting with 90. Really? Yeah, I see. Yeah, because if I have 60 here, then adding 30 would give me 90. Yeah. Because 90 is bigger than 80, then 80 doesn't really affect it. Okay, so let's try. Then what happens? Okay, let's try a different one. So let's say it's 10, 20, 60, and let's say it's 25, 90. So this is 85 maybe. It is 90 still, not 85. So 10 plus 20 is 30, but because 30 is smaller than 60, it has to be 60. then 60 plus 25 is 85 because 85 is bigger than or smaller than 90, it has to be 90. Is this right? Is this the way I should be doing this? $10, $20. So if this ordering was, let's say this is 80, so it's 20, 60, 60 plus, let's say this is 25, let's say it was 80, then I guess here the answer would be 85. Okay. I feel like I'm missing, okay, I have an idea as to what the algorithm would be that matches the pattern of answers and tasks, but I'm pretty sure there's some cases that I'm missing that will be wrong. But the basic idea would be you start off with your smallest, the task with the least excess, and then you proceed to the next task, add the minimum energy spend on that, and then bump it up to the required if that is higher. So here 10 plus 20 is 30, but because 60 is bigger than 30, then the energy of before this task would need to be 60 rather than 30. So if this was like 20 here, well, then this would be different, but if this was 20, then I wouldn't need to bump it. So for every tuple in tuples, let's say, okay, let me have a starting. I guess I should probably start with the cost of the first one. So tuples of 0, the requirement of that, and then for everything from 1 on. Actually, I'll just do an index here. Just do an index here. Let's say excess cost and the requirement is equals to tuples at k. And then I guess I'll say current energy is this. And I'm just going to go with a wild guess that it's just going to be current is equal to the max of current plus cost, or whatever the requirement would be. And then that's it. I think this works for the test cases. Misspelled current. Okay. Well, you win some, you lose some. Okay, let's go ahead and print the tuples. Okay, so which one do I want to parse? Probably the first one. So in theory, 1, 2 is the starting point. So you start with 2 energy. 2 energy plus 2 is 4. 4 plus 4 is 8. Why is it adding an extra 1? Current plus cost. Oh my god, I'm such an idiot. I specifically said that I wanted to skip the first task. Okay. Wow. Well, it works. I guess it's probably slow because of this thing here. Yeah, slow because of this thing. This thing I can just sort by index, or I don't need to create a new. So the basic premise of what my understanding of how to find a solution, I guess, based on the small amount of test cases here is lowest excess, take the cost, take the required cost of lowest excess, and then like for each subsequent task, after you sort by the lowest excess, then you just add in the required cost of it, or the energy cost of it, and bump that up to the actual requirement cost of it, if that's higher. But since I don't actually use the excess after I sort it, like the excess variable isn't used here, I can probably just sort in place and not create a separate array for it. So the task dot sort, I think the key equals lambda x, where x is each element, sorting it by x1 minus x0, x at 1 minus x at 0, x at 0, I don't think I need more than that. So this just sorts the tasks as the tuples will be sorted. And now I just need to use tasks. So the first task, the cost of it, and then for everything after that, I guess this would be task at k, pulled out the cost and the requirement. Okay, I think this is right, or I think this might work. Well, fuck me. Same exact runtime. Pretty much. Actually, the last one was actually faster for some reason. Okay. I mean, I think I need to sort. No? Am I wrong? Maybe I just need to sort by the tuple itself, by the excess. No, I think I do want the excess plus the excess and the other stuff. I wonder if there's a small Yeah, maybe I think maybe I can actually start with current equals 0. Yeah, and then just iterate over the tasks here. Yeah, don't have to do anything. I actually don't have to do any of this, or I can consolidate this. Guess I don't even need to answer. The answer is current. Because if it's 0, then and then when it does the 31st one, it actually adds the current plus cost, which is basically like the 0 plus the cost, and then it'll bump up to the requirement, which is basically, yeah, it's gonna be the same. Okay, so this is actually cost is task at 0, requirement is task at 1. I think that actually is the same, right? Okay. Do I have any sort of improvement here, or is sorting just like wrong? Okay. I'm trying. I'm trying. What more do they want from me? Let's simplify this code. I guess I don't. If I don't use a fine, if I actually use an if statement here, it might be slightly faster if yeah, so it'd be something like current plus equals task at 0, which what did I have here before? Okay, it was just this single statement, right? So if I just did current plus equals task at 0, if task at 1 is greater than current equals task at 1. Okay. Does this improve anything, or is it just slower? It's about slightly slower. Okay. Although it is 3 times this many lines, so it's not faster, and that's worse. Could I have done this without sorting, I guess? How would I have done this without sorting? I don't know, man. I don't know. There's some, I feel like this has to be without sorting, like the gap between this solution and like the rest of the curve here. That's basically linear versus n log n. Is it possible that I can just find the minimum delta and then work from there? I feel like that doesn't seem right. The minimum delta and work from there. Maybe though? Maybe it's the minimum delta. Is it the minimum delta? Do I actually need to start off with Could I have started off with any? So if I start off with saying I'm going to do 1, 3 as my last one, so that means my minimum is 3. Then if I did 3 plus 2 is 5 plus 10 is 15, 25, 33. So maybe I need to just start with any that has the minimum, that has the lowest thing. All right, I'm gonna do one last test before I just give up for the night. I don't think I just need to do my code before this. So how would I do this? Nah, I'm not done. I'm done. Thought about it. I don't feel great about just trying it. Okay. So what was the fastest random timing was 68. I got a positive for the memory. Okay, summary. Did some revisions of an idea for how to compute the smallest or the minimum required, the minimum starting energy. The basic idea is to work backwards from the task that has the lowest excess energy, where excess energy is defined as the required energy minus the cost energy. From there, or if the tasks are sorted from lowest excess energy to highest, then the final, then say tasks are sorted from lowest energy to lowest excess energy to highest. Iterate over that array, and for each subsequent task, increase the energy by the cost of the next task. But if that is still smaller than the required, increase current energy level to required. So for like, what's an example? So maybe I can use this as an example. So here, this has 10 excess, this task has 80 minus 25 is 55 excess. This has 40 excess, so the sorting of this would be something like this in terms of lowest excess to highest excess task. 0 excess, 40 excess, 55 excess. So you need to start with 10 energy, and then in order for you to do this task, or you start, or basically this has to be your final task. So, and this final task would need to have 10 energy, using up the 10 energy to get you to 0 once this is done. But anyways, so 10 plus 20 is going to give you 30. But because 30 is lower than the 60 here, then you need to bump up to 60. So basically, you need to have 60 energy heading into this task, spend 20 of it to be down to 40. 40, you spend 10 of it, and you're down to 30, but that all works out. In theory, if this was something smaller, let's say this was 25, you'd be 10 plus 20 is 30. 30 is bigger than 25, in which case you're good, because then like 30 energy is bigger than 25 required to do a task, and then going down 10. Anyway, so it's now 60. 60 plus 25 is 85. Because 85 is bigger than 80, then that's fine. So 85 is like the current level, so 85 would be the answer to this thing. Did several kind of several revisions of that same concept to simplify, reduce the code to the above kind of compact form. Previously I had like I created a separate tuples array where the tuples has this excess value, but you can just use a sorting key on an in-place sort of task array to do the same deal. I don't know how to do the other faster ways. I don't know what they do. Time complexity is going to be O of n log n, since it needs to sort by excess. I mean, I feel like that's necessary, but I also feel like this indicates that it's not, like it's maybe just an n of n based on the kind of submission speed compared to other solutions. I'm guessing this is not optimal, and that there is some O of n solution I'm missing. Like the O of n, I feel like you do need to find the task that has the lowest excess in order to start off, but then you can optimize. Maybe you can actually calculate the other tasks based on that without having to sort. Something like that is my guess. Basically, this is O of 1, since no extra space is needed. Alright, so at least my streak is still on. Come on, bro.